So here's the problem. So normally, let's say if you unplug the LAN 0 port, normal VRRP will fail over in about 3.5 seconds. And then the LAN traffic would come over, and then ECB would immediately send it to the data center. And then the return path, it still has to wait for a reclassification to find the next best path, which is going to be this. In the normal case, it would still take the flow classification timer, which is like set to 60 seconds if we haven't modified it. How can we do this in a faster way? So like, what did we build? First step, what we do is for a given site, we associate the EdgeConnects here, ECA and ECB, as part of a cluster. We give it the same site name or the cluster name. Then we use a single VRRP instance to track that cluster. So let's say if you're a VRRP master for that cluster, for that site, ECA is the cluster primary. And if you're the VRRP backup, you're the cluster backup for that site. Using the VRRP that you have running over the LAN side to determine who's the primary for that site. As soon as this guy becomes VRRP master, it announces, for this cluster, I am the cluster primary, right? Similarly, this guy goes, hey, for this cluster, for this site, I'm the backup. So on the DC's perspective, it still goes through the routing lookups, but we are injecting additional information. You have an overlay tunnel to ECA, and it also maintains a backup. So we are basically priming it for a failover. Like when this packet comes in, this lookup happens on a per packet basis. It's not after a flow reclassification or any other time. So like on a per packet basis, we will say, hey, who's the primary tunnel to go to that site for this overlay? And it will pick. You still need subnet sharing to find out who are the peers that I can use. But the metric we're going to override. If the ECB becomes a VRP master on the LAN side, it sends 3 messages using all the underlay tunnels to its peer saying, hey, I am the cluster primary right now. All this guy has to do is change his pointer for traffic forwarding. It immediately, in the next packet, it starts forwarding traffic towards the ECB. And this message, since it's immediate, but obviously it takes the WAN latency, right? So if you have a 10 milliseconds or 300 milliseconds, it will take that long for this message to show up and process and to program this. Configuration is only done at the cluster side. You assign a cluster or site name, which has to be unique, and then enable the cluster tracking. So you use the same site name, it's case sensitive, etc. And then you go to the VRRP and then enable this new capability called site cluster tracking for a single instance. Like let's say you have like 5 different VLANs or interfaces, you only have to enable it on one VRRP instance. Obviously, you have to do it on both sides of that VRRP instance. Configuration, verification, you see this ... square, that indicates you're a backup for that cluster. And if you put the mouse over, it will say primary device or backup device. From the subnet sharing perspective, from the DC's perspective, this is what you're going to see. We already had the metric and the AD, like this is the additional information. From this cluster tracking perspective, for this subnet, O2 is the cluster backup. O1 is the primary because the VRRP is set up that way. So from the flow table perspective, this is what it looks like normally. And this is the new field our engineers added. It says the primary node has changed. Okay, troubleshooting. How do you find the system ID or the RNID? It's on the show system. Appliance UI has it too. And then other useful one when you're debugging is show system site list. It will show up like this. Site ID 68, site ID 138, HA detected. And then it will say who's the master right now, who's the backup now. Upgrade consideration, again, like remember, one side sends this new update message, right? And the other guy needs to understand it. So like both sides have to have the same code, 9.60 above. The old code will like ignore this message. The worst case is like there's no fast failure.